Okay, lesson 6 for differentiation. We're going to be looking at equations of tangents. Now we came across tangents when we looked at circle. A tangent to a curve has the same properties, touches at one point, and it's a straight line. It's a straight line and we want to find the equation of it, which means we need to know two things. We need to know a point on the line and we need to know the gradient of the line. Now the tangent at any given point, well, we can use the point as our values for a and b when we're trying to find the equation of the straight line. The gradient, we discovered, is given by the derivative of the curve. So we'll differentiate the curve, we'll substitute in the x coordinate here, and that will give us the gradient at this point. We'll use these points a and b, and we'll use our straight line equation y minus b equals mx minus a. Okay, we're going to go straight ahead to so on page 8 we are asked to find the equation of the tangent to the curve with equation y equals x squared minus 3 at the point 2, 1. So the first thing we're going to do is we're going to differentiate this. So dy by dx is equal to 2x. To find the gradient, we're going to substitute the value of x, in this case 2, into the derivative formula. So we've got a gradient of 4. Now we're going to use our straight line formula. And we're going to remind ourselves of the things we're going to substitute in. We're using a gradient of 4. Our a will be 2 and b will be 1. So we substitute in as normal. Y minus 1 is equal to 4x minus 2. I'm going to multiply out the brackets. Y minus 1 equals 4x minus 8. And I'm going to rearrange so everything's on one side. 4x minus y minus 7 equals 0. Okay, all straightforward so far. We're not always given all of that information, and sometimes we have to do a little bit of extra work at the beginning. So we're going to move on to example 2. Now in the second example, we're given a curve y equals x cubed minus 2x, and we're asked to find the equation of the tangent at the point where x equals negative 1. Now we've only been given the x coordinate, so the first thing we're going to do is we're going to work out the y coordinate, and we're going to do that just by substituting into our original equation. So y equals negative 1 all cubed minus 2 times negative 1. Negative 1 all cubed is negative 1. Negative 2 times negative 1 is plus 2. So I've got a y coordinate of 1. So now I've got a set of coordinates. I need to work on the gradient. So I'm going to go back to my original equation. Y equals x cubed minus 2x. And this time I'm going to differentiate. So dy by dx is 3x squared minus 2. And to find the gradient at the point where x equals minus 1, I'm going to substitute the negative 1 into my derivative. So 3 times negative 1 squared minus 2. So the gradient is equal to negative 1 squared is positive 1, so that's 3 take away 2, which gives us a gradient of 1. So now we've got all the information we need, we can go to our straight line equation. Y minus b equals mx minus a. And we're just going to remind ourselves what we're substituting in here. So I've got m equals 1, a is negative 1 because that's the x coordinate, and b is positive 1 because that's the y coordinate. So we have y minus 1 equals 1 times x plus 1, so it's minus minus 1. Multiplying out the brackets, well, it's just 1, so y minus 1 equals x plus 1. And now I'm going to rearrange. So x minus y plus 2 equals 0. And that's our final answer. That's the equation of the tangent. Now the things that we need to be careful of in this type of example. First thing we did, if we look back here, is we calculated the y coordinate and we used the original function for that, because this point that we're trying to find is on the original function. Then we calculated the gradient. To calculate the gradient, we differentiated the function and substituted the x value into the derivative rather than the original one, and this gave us the gradient. Now, armed with all these pieces of information, we were able to go back to our straight line theory and use y minus b, substituting in the values we'd found. Okay, let's try one more. Okay, the third example, you're given a diagram and we're told that the function is defined by f of x is equal to 1 over x and x is greater than 0. We're asked to find the equation of the tangent to the curve at the point P. Now looking on the diagram, we can see the point P and we're given the y coordinate is 2. We don't know what the x coordinate is, but we know the y coordinate is 2. So, similar to the last question, we've got one of the coordinates, we need to calculate the other one. So we're going to do that by using the original equation. So I'm going to calculate the x coordinate by substituting the 2 in. So 2 is equal to 1 over x, which means 2x is equal to 1, which means x is equal to a half. That's the first part. I've now got one set of coordinates for P. Next thing I'm going to do is I'm going to calculate the gradient, and I'm going to do that by differentiating the curve. So we're given that f of x is equal to 1 over x. I can't differentiate it in that form, so I'm using my Indus rules to say that's the same as x to the power of minus 1. I'm going to differentiate by multiplying by power and reducing the power by 1. So negative x to the power of negative 2. I'm going to rearrange it using my Indus rules so that I can substitute into it. So it's the same as negative 1 over x squared. Now here you'll really see how important it is to substitute in, because we couldn't go using x to the negative 2. It'd be too tricky for us to substitute in. We've been given the value of x to be a half. So we're going to find the gradient by substituting a half into this derivative. So the gradient is equal to negative 1 over a half squared. Now a half squared is a half times a half, which is a quarter. Dividing by a quarter is the same as multiplying by 4. So the gradient here is equal to negative 4. Okay, so I've got a set of coordinates and I've got a gradient. I'm now going to use my straight line formula and substitute these things all in. So y minus b equals mx minus a. I'm substituting in a gradient of negative 4, an x coordinate of a half, and a y coordinate of 2. So y minus 2 is equal to negative 4 times x minus a half. Multiply out the brackets. And I've got y minus 2 is negative 4x Negative 4 times negative a half is positive 2, so plus 2. Then I'm rearranging. I'm going to put everything on the other side to make that x positive. So 4x plus y minus 4 equals 0. And that is the equation of our tangent for the third example. Okay, so answer the following questions in your jotter just to check your understanding. So what are the things you need to be able to find the equation of the tangent? There are two things that we always need. And what equation do you substitute into to get an x or y coordinate? And then what are the steps you take to find a gradient? There are two things that we did each time to find the gradient. Okay, we are now in a situation where we can begin exercise 6G. Question 1, which is unit level. Now, we've split this into two, this topic, because it's quite long. So there's going to be a second lecture on giving you examples 4 and 5.